Hello students, welcome to Anne's classes. Let's do special types of quadrilaterals, chapter 17. Page number 204. Question 2. The adjacent sides of a parallelogram are in the ratio of 5:4. Adjacent sides means the sides that come next to each other and they are in the ratio 5:4. If the perimeter of the parallelogram is 108 centimeters, find the length of its sides. So let's take the adjacent sides to be 5x and 4x. That means we can take 5x to be the length and 4x to be the breadth. So let's write that. So length will be 5x. The bigger number will take it as a length and the smaller number will take it as the breadth. Now perimeter is also given to us 108 centimeters. Now we know the formula of perimeter, isn't it? Perimeter is equal to 2 into length plus breadth. And perimeter is given to us 108 centimeters and this is equal to 2 into, and length we said let it be 5x and the breadth 4x. So now 108 centimeters is equal to 2 into 5x plus 4x, that is 2 into 9x. So 108 centimeters is equal to 2 into 9 is 18x. So now we can find the value of x alone. We can say x is equal to 108 divided by 18. Okay, that is, here we have taken x here and moved 18 to the other side, so it's become division. So when you divide 108 by 18, you get 6. So x is equal to 6. Now we can find the two sides. So the sides, the first one we said, let the sides be 5x and 4x. So 5x means 5 into x and x is 6. So 5, 6 are 30 centimeters. So the first side is 30 centimeters. The second side we said, let it be 4x. So 4x means 4 into x and x is 6. 4, 6 are 24. So we have found the two sides. The two sides are 30 centimeters and 24 centimeters. And we know the opposite sides are equal. So there will be two sides with 30 centimeters and two sides with 24 centimeters. So we can write it that way. That is, we can say length and breadth. Again, length and breadth. So these are the length of the sides, all four sides of a parallelogram, and this is our answer. Question 3. In the given figure, ABCD is a parallelogram. So we have the parallelogram here, ABCD. Now let's continue. If OA is equal to 6 centimeters, OA, this is 6 centimeters, this much is 6 centimeters. Okay, so this part, and AC minus BD is 2 centimeters. So that is an equation that we need to keep in mind. Now we have to find the length of BD, this diagonal we have to find the measure of. So that is what we've been asked to write. So now let's write what's given to us. ABCD is a parallelogram. OA is equal to 6 centimeters. AD minus BD is equal to 2 centimeters. Now one important property here of parallelograms is that diagonals of a parallelogram bisect each other. So the diagonals are bisecting each other. That means they're dividing each diagonal into two equal halves. So this diagonal AC is dividing this into two equal halves. The other one is also dividing AC into two equal halves. So this part OA is equal to OC. OB is equal to OD. Okay, because the diagonals bisect each other. So keeping that in mind, we can say OA is equal to OC, which is 6 centimeters. Now OA and OC are equal because it's bisected right in the middle. That means if this is 6 centimeters, this will also be 6 centimeters. And this one was already given to us. OA is already given, it's here. It's given in the question, OA is 6 centimeters. So we now know that this side is 6 centimeters and this side is 6 centimeters. So now let's find the length of this diagonal AC. So the length of the diagonal AC will be equal to OA plus OC, isn't it? OA plus OC. This is the diagonal AC. It's equal to this plus this. So, and we already know the measurement of OA and OC. So we can find the measurement of AC. So OA is 6 centimeters. OC is also 6 centimeters. So now we know the measure of AC. AC is 12 centimeters. Now let's look at the equation that's given to us. This equation has been given to us. Let's use that here. That is AC minus BD is 2 centimeters. So this is given to us already in the question. It's given to us AC minus BD is 2 centimeters. So now that we know AC, let's substitute with 12 centimeters for AC. So this will be AC is 12 centimeters minus BD will give us 2 centimeters. So now we can find the value of BD. BD will be equal to 2 centimeters minus, now this one, when we transpose it to the other side, becomes minus 12 centimeters. So this will be minus BD. So let me write it here. Minus BD is equal to minus 10 centimeters. And we want the answer positive. So we can remove the minus signs from both sides. So we can find the value of BD. BD is now equal to 10 centimeters. So this is our answer, 10 centimeters. Question 4. The diagonals of a parallelogram ABCD intersect each other at point O. We have a parallelogram here. Now if OA, now this is OA, is x plus y. So let's write that. So this portion is x plus y. And OC is 20. So this is 20. Then OD is x plus 3. That means this portion x plus 3. And we have OB is 18 and this is 18. So all these measures are given to us: OA, OC, OD and OB. Now we have been asked to find the value of x and y. So we have x here near OA. We have x here and y, and here also we have an x. Now we have to solve and find the value of x. So let's begin. ABCD is a parallelogram. OA is given to us. All these things are given to us. X plus y. OC is 20. OD is x plus 3 and OB is 18. Now let's use the property of parallelograms, which says diagonals of a parallelogram bisect each other. That means they cut the other diagonal into two equal halves. So let's make use of that property. That is, OA is equal to OC. That means x plus y is equal to 20, isn't it? So let's write that. So this means that x plus y, this implies that x plus y is equal to 20. And look at the other one here, OD. OD is equal to OB. And that also, what does it mean? Now OD is x plus 3 and OB is 18. So that is x plus 3 is equal to 18. So with the help of this equation, we can find the value of x. And once we find the value of x, we can substitute it in this equation and find the value of y. So let's use this to find the value of x. So x plus 3 is equal to 18. That means x is equal to 18 minus 3. So we have found the value of x. X is equal to 15. So now we know the value of x. X is 15. We can substitute it in this equation. X plus y is equal to 20. So let's write that. X plus y is equal to 20. And we know that x is 15. We just found out. 15 plus y is 20. So now to find the value of y. Y is equal to 20 minus 15. So 20 minus 15 is 5. So we have found the value of y. Y is equal to 5. So we have our answers here. X is 15 and y is 5. We have found the values of x and y. Question 5. One of the diagonals of a rhombus and its sides are equal. Find the angles of the rhombus. So this is the rhombus, and rhombus is a quadrilateral in which all four sides are equal. Now here they are saying one of the diagonals. So we have drawn only one diagonal. This diagonal is equal to the sides. That means this AC is equal to AB, it's equal to BC, it's equal to CD, it's equal to DA, all four sides. Now we have to find the angles of the rhombus. That is, we have to find angle A. This will be one side, this will be the other angle, this will be the third angle, and this will be the fourth angle. So we have to find all four angles of the rhombus. So let's begin by saying what is given to us, and what is given to us is one of the angle diagonals of a rhombus and its sides are equal. Then let ABCD be the rhombus where AC is the diagonal, this is the diagonal equal to its sides. Now, since AC is equal to the sides of the rhombus, since AC is equal to the sides, we have two triangles formed here, isn't it? There are two triangles and one is ABC. This is one triangle, then ADC, this is the other triangle. They will be two equilateral triangles. And what are equilateral triangles? Equilateral triangles are triangles which have three equal sides and three equal angles. So these three sides are equal, these three sides are equal. So we have two equilateral triangles here. So first, let's find the angles of the equilateral triangles. That is this part, and this. These are the three angles of this triangle. Similarly, we have here. So let's find the angles of the equilateral triangle. We know that the angles are all equal and they are 60 degrees. So let's write them down. So that will be angle BAC. Angle BAC will be equal to angle BCA, which is equal to angle ABC, and they're all 60 degrees each, because in an equilateral triangle all three angles are equal and they're all 60 degrees each. So we have this. Similarly, from the other equilateral triangle we can say angle DAC is equal to angle DCA is equal to angle ADC, and they're also equal to 90 degrees each. So now that we know the angles of the equilateral triangle, we're going to find the angles of the rhombus. So let's start by finding angle A. This whole thing is angle A. So let's mark that. So this is angle A. So let's write now angle A. How do we find the value of angle A? Angle A will be equal to angle BAC, that is this part. Angle BAC, this part, plus angle DAC, this part. Okay, so that is equal to angle BAC plus angle DAC. Now how much is that? That is angle BAC. Here let's see, let's have a look. Angle BAC is how much? 60 degrees. Angle DAC is how much? 60 degrees. So let's write that. So that will be 60 degrees plus 60 degrees, which is 120 degrees. So we have found the value of angle A. Angle A is 120 degrees. How do we get that? This is 60 here and 60 here. Together it's 120. And we also know that the opposite angles of a rhombus are equal. The opposite angles of a rhombus are equal. And what is opposite angle A? Angle C. That means angle C is also 120 degrees, because angle C is equal to angle A, which is equal to 120 degrees. So we have found the value of angle C also 120 degrees. And angle B is here. This is angle B, and this is an angle of the equilateral triangle. So we can write that angle B is equal to angle ABC, isn't it? It's equal to angle ABC. And we have already found angle ABC. Angle ABC here is 60 degrees. And we are talking about this angle B. This is equal to angle ABC. And that is 60 degrees. So we have found the value of angle B. Angle B is 60 degrees. So we have this. Now we can use the property of opposite angles of a rhombus are equal. So opposite angle of B is D. If B is 60, D is also 60. So let's write that. So angle D is equal to angle B, which is equal to 60 degrees. So we have found all four angles. So let's see, angle A, angle B, angle C, and angle D. Let's see how much these are. Angle A we said is 120 degrees. Angle B is 60 degrees. Angle C is 120 degrees. And angle D is 60 degrees. So we have found all four angles. You can also check your answer using the property sum of interior angles of a quadrilateral is 360 degrees. So add up all the angles and see whether you get 360 degrees. Question 6. In a parallelogram ABCD, E is the midpoint of AB and AB. So here we have parallelogram ABCD. E is the midpoint of AB. So we have E here, it's the midpoint of AB, and CE, that is CE, this line here bisects angle BCD. BCD, it's bisecting this angle. That means it's cutting that angle into two equal halves. Now we have to prove a few things. The first one is prove that AE, that is AE is equal to AD. This and this are equal. We have to prove. So let's begin by writing what's given. ABCD is a parallelogram. E is the midpoint of AB. CB bisects angle BCD. So let's put that angle symbols. Angle BCD. We have to prove that AE is equal to AD. So where do we have AE? This is AE and that's equal to AD. We have to prove. So first part is a part of the proof is that AB is parallel to CD. And that we know because this is a parallelogram, that means this is given to us. AB is parallel to CD. So in that case, we can take EC as the transversal. If EC is the transversal, the angle here, we can call it angle 1. So the angle that is here, that is angle 1, and the angle here, angle 2, will be equal. Why? They are now alternate angles, and alternate angles are equal. So let's write that. Angle 1 and angle 2 are equal to each other. Angle 1 is equal to angle 2 and the reason is given, alternate angles. So let's take this as equation 1. We're going to be using this again. So this is equation 1 and we'll be using equation 1 in the other equations. Now look at the angle on this side. This angle, let's mark it as angle 3. So this angle 3 here will be equal to angle 1. Now how will that be equal to angle 1? Because that is also given to us. What does it say? CE, that is CE, this line bisects angle BCD. BCD. Bisecting means dividing this angle into two equal halves. That means these two are equal. So we can say angle 1 is equal to angle 3. So let's write that. Angle 1 is equal to angle 3 and this is given to us. It's given to us. So this will be equation 2. So let's write this as equation 2. So far I hope you've understood. Angle 1 is equal to angle 2 because they are alternate angles. Angle 1 is equal to angle 3 because it's given to us in the question that this has bisected the angle into two equal halves. Bisecting means dividing into two equal halves. So now from equations 1 and 2, we can say 2 is equal to 3 because 1 is equal to 2 and 1 is also equal to 3. That means 2 is equal to 3. That means these two angles are equal. So let's write that from equations 1 and 2. We can say that angle 2 is equal to angle 3. So now these two angles are equal. So if these two angles are equal, the sides opposite those two angles will be equal. So this is one side, this is one side. These two sides will be equal. So this is equal to this. These two sides are now equal. And what is the reason? They are opposite sides of equal angles. So for angle 2, the opposite side is this. For angle 3, the opposite side is this. And these two are equal because the angles are equal. So let's write that down. So EB or BE is equal to BC. BE is equal to BC. And what is the reason? Sides opposite to equal angles. So now we know that BC is equal to EB and we also know that BC is equal to AD. How do we know that? Because these are the sides of a parallelogram and the opposite sides of a parallelogram are equal. That means this is also equal. So now we have BC is equal to BE and BC is also equal to AD. So let's write that also. So BC is equal to AD. And what is the reason? Opposite sides of a parallelogram are equal. Now again, if you continue looking, now BE is equal to AE because this has cut it here and E is the midpoint of this line. If it's a midpoint, it has cut this line into two equal halves. So this part, that is BE, is equal to AE. So this part and this part are also equal. So let's mark that also. And let's write that, that is BE is equal to AE. And what is the reason there? There is a midpoint there. It is given to us already this way. It is given that E is the midpoint. So AE and BE are equal to each other. So now we're going to substitute for BE. So BE, if you look here, BE is equal to BC. And look at BC. BC is equal to AD. So in place of BE, I can write AD. So let me write that. So AD is equal to AE. And this was what we have been asked to prove. AD is equal to AE and we have proved. I hope you understood how I got this part. Okay. So here I have BE, isn't it? So BE, looking at this, let me draw there. So here when you look at this, BE is now equal to BC and BC is now equal to AD, and that is the AD that we have written here. So AD is equal to AE. So we have proved that AE is equal to AD. So you can write hence proved. So we have proved that AD is equal to AE. This is the first proof that we were supposed to do and we have proved it. Question 2, we have to prove that DE bisects angle ADC. So E is the midpoint and from D we have to draw a line and prove that DE is bisecting this angle ADC into two equal halves. Bisecting means dividing into two equal halves. So what is given to us? Parallelogram ABCD. E is the midpoint and we have to prove that DE bisects angle ADC. So let's begin our proof. So let's take triangle. Let's take the triangle DAE. So look at the triangle DAE. That is this triangle. Now in the previous question we proved that AE is equal to AD. So we have marked them as equal sides. Now we know that angles opposite to equal sides will be equal. So this angle and this angle are the angles opposite. So let's mark this as angle 4 and this as angle 5. They will be equal to each other because they are angles that are opposite to equal sides. So let's write angle 4 is equal to angle 5. And what is the reason? Angles opposite to equal sides. So this is the first point. Angle 4 is equal to angle 5. Now let's look at lines AB and DC. This is AB, this is DC, and as you can see they are parallel to each other. Let's mark that. They are parallel to each other. Now if these two are parallel to each other, we can take AD as the transversal. Okay. You can also take DE as a transversal. So now consider these two lines to be parallel and DE is as the transversal. Then in that case, this angle here, we can call it angle 6. Angle 6 and angle 5 will be equal to each other. Now how are they equal? Angle 6 and angle 5. So angle 6 and angle 5 will be equal to each other because we have considered AB and CD as parallel lines and we have taken DE as the transversal. So 6 and 5 are alternate angles. So we can write that. We can say angle 5 is equal to angle 6. And what is the reason? Alternate angles. So here we have found that angles opposite to equal sides 4 and 5 are equal. Alternate angles 5 and 6 are equal. So that means if 4 is equal to 5 and 5 is equal to 6, that means 4 is equal to 6, isn't it? 4 is equal to 5 and 5 is equal to 6. That means these two angles are equal. So what does that mean? It means that this line DE has bisected this angle into two equal angles that are 4 and 6. So 4 and 6 are equal to each other. So we have proved that DE bisects angle ADC. And here you can see there are two angles and both these angles are equal. We have just proved it. So this also we have proved. So we can write hence proved. Now the third thing that we need to prove is that angle DEC is a right angle. That is DEC. This point is a right angle. This is we need to prove. So again what we're given is ABCD is a parallelogram. E is the midpoint of AB. Now to prove that angle DEC is a right angle. So first we start the proof by saying AD is parallel to BC. So if AD is parallel to BC, let's mark that. So this time we are taking these two lines as the parallel lines and we are taking CD as the transversal. So if these two are the parallel lines and this is the transversal, then the whole of angle D plus the whole of angle C will be equal to 180 degrees. That is angle D plus angle C will be equal to 180 degrees. And what's the reason? They become co-interior angles when they are cut by the transversal. So now in place of angle D, we have 6 here for this side. Now this side also will be 6. Why will it be angle 6? Because it's cut by a bisector. Bisector means it's cutting this angle into two equal parts. So this part is 6, this part is also 6. If it is 1 here, it's 1 here. So in the place of 6 and in the place of D, I'm going to write 2 of angle 6. Similarly, in place of angle C, I'm going to write 2 of angle 1. When you add up both, you get 180 degrees. So here, because 2 is common, I'm taking it outside and inside I'm writing only angle 6 plus angle 1 because 2 is common is equal to 180 degrees. Now to find only angle 6 plus angle 1, what do? I say 180 degrees divided by 2. So angle 6 plus angle 1 is equal to 180 by 2 will be 90 degrees. So I hope you've understood. These two angles, when I add it up, I get 90 degrees. Now if I'm going to take angle DEC, then what should I do? I should remember that this angle 6 plus angle 1 plus angle DEC will all add up to 180 degrees because they will be the sum of the angles of the triangle, and the sum of angles of a triangle is equal to 180 degrees. So let's write that. So angle 6 plus angle 1 plus angle DEC. Together, they form the three angles of this triangle DEC. Okay, so will be equal to 180 degrees. Now, if I have to find only DEC, I'm going to substitute here angle 6 plus angle 1. Here, what did we get? Angle 6 plus angle 1 is 90 degrees. So, I'm going to substitute this with 90. So, that will be 90 degrees plus angle DEC is equal to 180 degrees. That means if I have to find angle DEC, now let me continue this here. If I have to find angle DEC, what do I say? This is equal to 180 degrees minus 90 degrees. So angle DEC is equal to 180 minus 90 is 90 degrees. So what have we found here? That angle DEC, this portion is 90 degrees. So this is 90 degrees. And what were we asked to prove? We were asked to prove that angle DEC is a right angle. A right angle means an angle that's equal to 90 degrees. And we have proved that angle DEC is 90 degrees. So you can write hence proved. We will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.